Cody and I are here to tell you about Experiment 9, determination of water hardness by complexometric titration.
Introduction. So to begin this lab, you grab a sample method. You could go down to the lake, but instead we chose to use regular tap water, which is a lot easier. Save the legs. And then for that, you use the titration for the analysis and all that. And after that, you gotta use the standardization of solution of the EDT to get those water solvents.
This lab also showed us how to conduct a complexometric titration to determine the water hardness of the sample. By determining the water hardness, we use calculations of calcium carbonate to find the hardness of it. To start off the experiment, we collected the grab sample.
Yeah, and while doing that, it represents the conditions present in the source at the extract minimum location, which was the date, and when it was 11/11/13, and the time was around 6 o'clock-ish. And to grab that sample, you use a 500 milliliter bottle, and then put the tap water in, which we used. And that's how you get the water.
We then prepared the sample for the carbon dioxide to be released. If the sediment was present, if we went to the pond, we would use a filter to filter that out, but since we used tap water, we didn't need that. After we got the grab sample, we poured 100 milliliters of the water into each of the 4 flasks. And then after we did that, we acidified the sample by putting in 6 more of HCl to turn it pink.
Once you've done that, you take your first flask that you filled that up with and add 3 to 4 drops of the red indicator so you can find out, distinguish it from other ones. And after that, you got to add the 0.5 meters of NaOH drop by drop until it turns to the pinkish yellow that you get. And usually takes around like 20 drops-ish. And then next, add the 2 milliliters of the pH 10 buffer and approximate 300 grams of the black tea indicator, which helps indicate the different changes from it has. And then make sure to repeat all these steps with the other 3 flasks.
After you do that, you determine the water hardness. You fill the burette with the standardized EDTA solution. And when you add the EDTA to the flask, the color will go from red to blue. It will pass through a purple color. You're going to want to go slow and take your time doing this to get accurate results. And then when you record your results, record the initial and final volumes of EDTA. So the results and data we have here, we have the balance equation of calcium carbonate dissolved in water.
And the bottom one is the balance equation showing how the Ca2 complexes with the EDTA, which you get from your experiment.
It's actually equilibrium, so there should be one there, and also one there. The balance equation for the Ca2 plus complexes with the EDTA. Ca2 plus, the natural log of the EDTA, equilibrates with the calcium EDTA2 plus the natural log.
Sorry if you can't see that. Here are the results and the data that you get from the EDTA and all that, and then the scratch sample that we didn't really use in sample 1, 2, and 3. Pretty much it.
This table shows the water hardness that we got from the calcium carbonate. We're going to show you how to get that. So we had, for each of the samples, we had 135 milligrams per liter for the calcium carbonate or water hardness. I'll show you how to get sample 1. So it's going to be the change in volume of the EDTA multiplied by the concentration of the EDTA, and then that will equal the number of moles. So if you go back to the table before, here's your numbers. So you're going to use what? 0.0054 turned into liters. So multiplied by 0.025 moles. And that's going to give you 1.35 times 10 to the negative fourth moles. And then you'll take that number and then multiply it by 1,000 milligrams to get 0.135 milligrams. And then once you get that, you divide it by 0.001 liters to get 135 milligrams per liter. And that's what the hardness of calcium carbonate is for the first sample. And then you would follow each procedure for that on each of the samples. And then to get the average, we just added up the 3 samples of this, divided it by 3. And then the standard deviation.
Here's the equation for the standard deviation. I don't know, I'll bring the red off, so I'll just write the equation out. And you just put the average you got with all the samples, and just do that in square, and then get the standard deviation.
The water hardness classification of calcium carbonate was between 100 and 200, so it was considered slightly hard. What I learned in this was how to use the titration and use a grab sample to find the hardness by using this equation right here and finding the hardness of calcium carbonate.